Alright, good afternoon everyone. Today we were gonna explain about our project. Our project is the switching mode power supply. So the first slide we have.
Harus introduction dulu, Cok. Di ininya, apa namanya, ketentuannya.
Hello, good afternoon everyone. Today we were gonna explain about switching mode power supply progress. So the
I will introduce you to my members. Before we continue, I would like to introduce my members.
Alright, good afternoon everyone. Today we're going to explain about switching mode power supply. So the first one we have introduction first. So my name is Nopal Rozan and my team is.
My name is Tian Setiawan.
My name is Glenn.
My name is Rifki.
Okay, don't waste the time, right? The first line we have electrical design can be explained by Deva and Glenn.
So I will first explain that. I will explain the absence of schematic that is SMS. Okay, the first is connector. The connector is the serve as the main gate or physical entry point at the point the AC voltage, and then there is a fuse. It is our system first line to defend. If malfunction occurs happen in circuit like subsequent or overload cause to massive spike current, the element inside the fuse is melt and cut off the power. So it prevents damage to other component and avoid risk of fire. And then is ME filter. The ME filter is act like protective wall because the high frequency of noise is caused by high speed of switching process. And then the AC voltage flows to the bridge rectifier. In bridge rectifier, it consists of 4 diodes. It converts the AC into AC voltage to DC voltage, and the resulting is a stable and high DC voltage output. And then the last is main converter. The way it works is the IC, the controller IC is act like a brain. Is command the MOSFET to turn on and turn off thousands of times for a second. When it on, the high DC voltage is it is activate the magnetic field, but there is no output. But when the switching is off, the energy in magnetic field is released to secondary side. So that the energy to the load, and this rapid cycle is continuously and in the very high speed, so it provides the stable and efficient power supply to the load. I think it's for me. Please explain the next.
Okay, so below the power supply system is what we call protection system. This system consists of 3 different protections: over current, over voltage, and short circuit protection. First, for the overcurrent protection, when the MOSFET receives too much current, the current flows through on the sense resistor, which is located on the third pin, which is the current sense pin. If the current is too high, then the resistor will send signal to the current sense pin, and then it will trigger the short circuit protection and the overcurrent protection. Because both the short circuit protection and the overcurrent protection works in hybrid. For the overflow protection, it is covered by the PC817 optocoupler and the TL431 transistor. When the voltage is higher than the recommended limit, the optocoupler will send signal to the voltage reference, and then it will reduce or cut off the PWM pulse module. That is all from me. Back to Nopal.
Alright, so thanks for defining that. Next slide we have mechanical design can be explained by me. So the mechanical design is right there. As you can see, we have a 4-channel in this design. So it can be supporting by IRS. So we have a 3-side airflow in left, right, and on the top. So we use the honeycomb holes in there. So we use red light and green light for the indicator too, and we use cooling fan for the cooling system in the case. So I think that's all for me. So that's all for our presentation today. We were gonna open a Q&A session. So anyone have a question? Okay.
I want to ask you guys about the mechanical design.
Alright.
Why you guys are using honeycomb core based system?
Okay, thank you for your question, Hanif. So I will explain why we choose honeycomb ventilation to be designed. Because the honeycomb design is open area large percentage, then circular pattern in the same total array. That's all for me.
That's clear.
Thank you.
Anyone have a question?
I want to ask,
Right.
so how if there's some fault signal detection if there's fault signal detection on your system?
Okay. Thank you for your question, Stephen. The question sounds great. Okay, so I will explain the LED fault there in every channel. So as Nopal explanation about the design mechanical, so the red LED is only a visual indicator. The circuit protection is to detect the fault. So in example is short circuit protection in the when the channel 3 is do increase current drastic, so the protection circuit will be cut off immediately and limit the current and send a signal from the LED lights to activate the fault. I think that's all for me.
Alright, thank you. I think that's clear.
Alright, maybe that's all for our presentation today. And thanks for your attention and your question for this session. I think that's all. And thank you. Good afternoon, everyone.
Good afternoon.
Thank you.